Yeah, welcome to Easy Learning tutorial class on YouTube. You are welcome. We appreciate you watching this YouTube. On this today, what we'll have for you is what we call topic normality in analytical chemistry. This is normality in chemistry. We are going to talk about normality, and there is a question they give us in this normality. Look at the question on this board. We said a solution of 0.280 molarity of tetraoxosulfates is available. They said, what is the normality of this solution when used in the following reactions? They said, number one, look at the reaction. The reaction of this man with lead, reaction of this man with hydrochloric acid, reaction of this man with water. That's what they show us here. But then, before we go into solving this, let us know some materials or parameter which will help us to solve it. Because going straight to solve it, you may not understand it properly. That's the reason why we needed to know some parameter we needed to know for you to solve it well. We said solution. Looking at this parameter, we said the equivalent weight of any material is the weight which would react with or being produced by the reaction of 7.99 gram of oxygen or 1.008 gram of hydrogen. We are talking about the equivalent weight of any material is the weight which would react with, or being produced by the reaction of 7.99 gram, which is the mass of oxygen, or 1.008 gram, which is mass of hydrogen. Then we said for acid or base or salt, gram equivalent weight, that's in gram, equivalent weight in gram. Gram equivalent weight is equals to formula weight, which we'll call molar mass. I say formula weight, which means molar mass over charge. Let us understand what I mean by this. Gram equivalent weight equals to formula weight, which we'll call molar mass over charge. For example, look at the example I gave here. I said tetraoxosulfate 6 acid ionized. When it ionized, hydrogen will be produced. This hydrogen is what we call proton is produced, which is 2 hydrogen plus this radical, which is what I call radical. Therefore, gram equivalent weight equals to, look at the formula we say, look at our formula here. We say formula weight or molar mass over charge. Then we now look at molar mass of this man. Molar mass of tetraoxosulfate 6 is 98.08. If you calculate the molar mass, it's 98.08, which is the formula weight. Divide by the charge. What's the charge? The proton, which is hydrogen. And how many charges do we see there? 2. So we divide it by 2. Which means the hydrogen, what it means, the number of hydrogen is going to release, which react with it. Remember what we said here? We said the equivalent weight of any material is the weight which will react with or be produced by the reaction of this oxygen or this of hydrogen. So as he reacts, he releases these 2 hydrogen. That's what we'll see here. We use it to divide the molar mass, and it gives us what we call gram equivalent weight. So to calculate gram equivalent weight, you see how we calculate it. You see the formula. Then we'll talk about for redox system. What do you mean by redox system? Redox reaction. Assuming that in redox reaction we are asked to calculate equivalent weight, we'll begin to talk about gram equivalent weight in redox reaction is equals to formula weight, which we know as molar mass, divided by charge in oxidation number. Charge in oxidation number. We say gram equivalent weight equals to formula weight, which we call molar mass, over charge in oxidation number. Then we'll begin to talk about formulas We said equivalent weight equals to molar mass of the substance over weight of hydrogen. We are going to see this when we begin to do calculation on this so that you will remember them. Times 1.00 gram of what? Gram, which is hydrogen. We are talking about hydrogen here. When we talk about equivalent weight, also we say mass of the substance over weight of oxygen. And times 7.99 gram, which is the weight of oxygen over there, which we have said. What does it mean? It means that for us to calculate the equivalent weight, it's talking about what reaction that will produce hydrogen or oxygen. If that reaction produces hydrogen, look at what we are going to use. If that reaction produces oxygen, you use this. Then now, let's go into normality. We said normality is the number of gram equivalent weight. You see the reason why you first of all to deal with equivalent weight we come to normality. We said normality is the number of gram equivalent weight. If you look at here, we said normality is the number of gram equivalent weight of a solute per liter or dm cube. You know that 1 liter is same thing as 1 dm cube. What we say per liter or dm cube of a solution. That's the definition of what? Normality. Is the what? Is the number of equivalent weights of a solute per liter per dm cube, per liter or per dm cube of a solute solution. Full stop. We said normality can only be calculated when we deal with reaction. So we cannot talk about normality without talking about reaction. It's only in reaction which produce either hydrogen or oxygen, we begin to talk about what? Normality. So without reaction, we don't talk about what? Normality. We said because normality is a function of what? Equivalent weight. Is a function of equivalent weight. That normality depends on the equivalent weight. Then now, let us look at the formula to use to calculate normality. We said normality is equals to molarity times N. And what is N? N is the number of proton exchanged in the reaction. I'm coming again. Normality is equals to molarity times N. What is N? N is equals to the number of proton exchanged in a reaction. What is proton? Hydrogen. The number of hydrogen that reaction will produce is N, which is when you turn it to the molarity of the solution, it will give you normality. Second formula to calculate normality. Number 2, we say normality equals to equivalent weight of a solute over 1 liter or 1 dm cube or 1000 cm cube, which we call volume of a solution. This 1 liter or 1 dm cube or 1000 cm cube is a volume of solution. So we now see that 1 liter is something at 1 dm cube and 1 liter is something at 1000 cm cube. So we say equivalent weight of solute divided by 1 liter will give me what? Normality. Third formula, because we're going to use this now. Third formula. Normality equals to concentration in gram per liter. Concentration in gram per liter or gram per dm cube divided by equivalent weight. These three formula is what you needed to put in your brain while waiting to calculate normality. These three formula is what you're supposed to have in your brain. You have to bring it offhand. Immediately you talk about normality. And also, this formula and this formula is what you use to calculate equivalent weight. Look at this formula. Is what we use to calculate what? Equivalent weight. With gram equivalent weight equals to formula weight over what? Charge. And what is charge? What hydrogen that will be released or oxygen that will be released. Then now, after we have known this, let us go into this question. Look at the question they give us. They say a solution of this, look at the what? The molarity of that solution. What is this? Molarity, which is 0.20 molarity of the which solution this is available. That is molarity. And they say, what is the normality of this solution when used in the following reaction? Look at this man. Then look at this man. This man now react with this to produce this. If this man now dissolve in water, disassociate in water, it will produce 2 lead, which means 2 hydrogen have been left this man. For this man to react with lead exchange 2 hydrogen. And that 2 hydrogen implies, let me clean here so that we'll solve those things immediately. That 2 hydrogen implies that N is what? 2. When I say number 1, A, this A, it means that what? N, which is what? N is equals to what? 2 hydrogen. Hydrogen is what's released from here. How did I know? H2SO4 react with PD, and what does it give you? Lead. What does it give you? It will give you lead XO4 plus H2. That means he produced 2 what? Hydrogen. Using our formula, we say normality, our formula equals to molarity times N. And what is the N? This gives me the molarity of the solution is 0.2 times N. What is N in this case? 2 hydrogen, which is 2. My answer becomes 0.4 normality. That is the answer for the first question here. This gives me the answer 0.4 normality for this particular question, this number. The B question, looking at that B, you see that hydrogen chloride react with this man, liberate 1 hydrogen from this man. He released 1 hydrogen from this man. You know that this man is 2 hydrogen, which we say the tetraoxosulfate 6 acid hydrogen. That's tetraoxosulfate 6 acid. You see the 2 hydrogen. This man reacts with this, and he liberates 1 of this, and they form it. What does it mean? It means that H2SO4 react with chlorine, 2 chlorine, then give me what he produced is HXO4 minus, there's 2 minus, why I put minus, there's remaining 1 hydrogen plus Cr minus. You see that this is 1, reacting this man, he removed 1 of the hydrogen. So what he released is 1 of the hydrogen. That means he liberated, he reacts with 1 of the hydrogen, means that what? It means that N is equals to 1 hydrogen in that question, 1 hydrogen. Then using our normal formula, we say normality equals to molarity times N, which means 0.2, which is the molarity, times 1, and that will give me 0.2 normality. For the second question, that's our answer for the second question. That will give me that for what? Normality. Then let us go for the question number 3, which is number C. Question C. Question C is saying, looking at the question number C, I think you got this. We said that question number B, that the B question said normality equals to molarity times N, which gives me 0.2 times 1. In this case, N is 1, which gives me 0.2 normality. That's our answer. Then C, let us go to the reaction of C. You see that this man, which is H2SO4 react with water. He react with water. And what happened? When he react with water, one hydrogen was lost. Have you seen it? There's one oxygen, I need to say, was lost. You see this man? The hydrogen is there, but one oxygen was lost. There's no more hydrogen in this case. In this case, it's oxygen. When he reacts with water, one oxygen was what? Lost to complete the reaction. And you see the water is complete here. This is water. Are you getting what I'm saying? So one hydrogen was what? Lost. And that hydrogen is 1. Therefore, N, number of N. Therefore, N is equals to what? 1. Are you getting what I'm saying now? 1 what? Oxygen was exchanged. Was what? Exchanged. Therefore, we now say normality equals to molarity times N. And that will give us, what is our molarity? Molarity is 0.2 times 1. Therefore, my normality of this question becomes 0.2 N. N stands for normality. Are you getting what I'm saying now? So this is answer to those questions they give us. Then second, we have to know this formula for molarity, the normality, this first and second and third. Our next question, you will see when to use this formula and when to use this. We use this one for this question because the molarity and the number of charge that being displaced or hydrogen and oxygen were given. But in the case where we are not talking about hydrogen, we will see when to use this in next class. So this is the reason why you needed to subscribe in this class for next class so that we can be able to prompt you whenever we post for the next class. This is what we have for you today. Love this class, subscribe to this class, comment, share to your friends, and see you in the next class. Thank you.